For most of human existence, the night sky was a mysterious thing. Glimmering points of light dotted the dark expanse, and in their patterns we saw reflections of our stories and tales, immortalized in the cosmic sea above. For millions of years, those stories were all we knew of the heavens. It was only in the last few centuries of our species' existence that we began to discover the secrets of the vast night. And it was merely decades ago that we caught our first glimpse of alien planets orbiting our neighbor stars. Our knowledge of our planetary kin has only grown since. Join me on a journey to worlds beyond our own, to the alien worlds we know as exoplanets. The term exoplanets refers to any planet located outside of our solar system. Most stars that dot the night sky have an exoplanet companion, often multiple. They can be even found alone, so-called rogue planets drifting through the galaxy in eternal darkness, unlit by any star. As in our own solar system, there are many types of exoplanets, roughly grouped into 4 disparate categories: gas giants, Neptunian, super-Earth, and terrestrial. Gas giants are planets composed mostly of gas, forming an impenetrable atmosphere that grows denser as you descend toward the hidden solid core. Although a very broad definition, such giants are usually categorized by their size, with larger gaseous planets falling under the gas giant umbrella. The other type of gas-dominated planets are Neptunian worlds, whose smaller size and colder nature differentiates them from the huge gas giants. Indeed, they are often known as ice giants due to the fact that they form in the outermost reaches of a solar system, like our Uranus or Neptune. Closer to the stars of our galactic neighborhood lay more familiar planets. The terrestrial and super-Earth categories hold the rocky planets, of which our home is one. Terrestrial planets are the smaller bunch, and are defined as rocky planets within 1/2 to 2 times Earth's radius. These planets typically orbit close to their stars, a fact which, in conjunction with their small sizes, makes them difficult for scientists to discover. Easier to find are their heftier cousins, the super-Earths. These giant worlds are quite common in the galaxy, though our solar system lacks one. Because of their abundance and relative stability, scientists believe life outside our solar system may be more likely on one of these giant, mysterious planets. They are often found alongside smaller Neptune-like planets, known as mini-Neptunes, leading some to think that there may be a connection between the two. In this system, far above the galactic disk, a mini-Neptune even orbits a larger rocky super-Earth, showing how large these worlds can grow. Although it is common for rocky worlds to pale in size before their gaseous counterparts, this does not always hold true. The success of the cast of exoplanets that populate our galactic stage is hugely dependent on their stars. A brush too close to an energetic young star could cost a gas giant its atmosphere, and a position too far from a smaller one could fling a planet into the dark interstellar void, where it would slowly cool for millions of years. The star of a planet is vital, especially as stars vary so greatly in their attributes. Stars are usually classified by their temperatures, which is revealed to us through their color when viewed. O, blue, B, blue-white, A, white, F, yellow-white, G, yellow, K, orange, and M, red. Bluer stars are hotter and brighter, whereas redder ones tend to be cooler and smaller. This does not hold true for the entirety of a star's life, as after the main sequence, where this does apply, many balloon into colossal red giants as they burn the last of their nuclear fuel. Our star is a G-type yellow dwarf, a class of star which is not exceedingly common in the galaxy. More common are the K-type orange dwarfs, which are cooler but longer-lived, and M-type red dwarfs, the most common type of star in the galaxy. The multitudinous types of stars are important for almost every area of extrasolar research, but almost more importantly, they are crucial to an ongoing, species-wide search for an answer to the age-old question, are we alone? As long as we have looked to the stars, we have wondered what secrets they may hold. Though for thousands of years we knew only the stories we saw play out in their cosmic arrangements, we now know that there are more amazing truths lying behind the darkness of the night. Since the day we opened our eyes to the endless universe above us, we have wondered, is there anyone else out there? We may soon have an answer. Decades ago, the physicist Enrico Fermi realized the universe was too quiet. Back-of-the-envelope calculations told him that given how old the universe is, why have we not seen any advanced civilizations stretching across the stars? Simply, where is everyone? Fermi's silence has some troubling implications. Some say, perhaps we just aren't looking hard enough. Some might say ascending to the stars is impossible. Truthfully, we don't know. Life could be all around us, simply invisible to our limited technology, or we could be alone in an empty universe. Although we have not found an answer yet, scientists believe that there is almost surely other life out there. On our planet, organisms have found a way to thrive in the most hostile environments, from scalding hydrothermal vents to frigid glacial ice. Some life can even survive in the vacuum of space, conditions that are among the most extreme in the galaxy. Scientists contend that life as we know it could potentially form on any planet with water, primarily in liquid form. To this end, they have calculated an area around each star, the habitable zone. Also known as the Goldilocks zone, this is the area around a star in which liquid water can be present on a planet's surface. The range where water can form is very different for each type of star, as their temperatures range so greatly, the zone could sit deceptively close or stunningly far away. It is a delicate balancing act. Life as we know it can likely only form in this thin band. With all we now know about our extrasolar planetary companions, it is amazing to think that the first time we caught a glimpse of them was barely 3 decades ago. In 1992, the first exoplanets were discovered around a pulsar 2,300 light-years from Earth. They are dead, irradiated worlds, orbiting a powerful and hostile star. But for scientists, they were perfect for discovery. By measuring the timing of the pulsar's destructive blasts, they were able to determine the existence of 2 planets, then later, 3. By far the most effective method of discovery is the transit method, which achieves its success by measuring the dip in brightness when a planet passes in front of a star. Other methods include measuring the change in light as a star moves due to a planet's gravity, or even measuring the infinitesimal curve of light rays as they bend around a planet's gravity well. Altogether, these methods make a formidable force for seeing the concealed. All told, they have found 5,241 worlds beyond our small system, bringing us ever closer to truly being a species of the stars.